So we read that there are three ways to evaluate limits. Okay, you can evaluate limits numerically. And numerically just mean a table, okay? Or you could look at it graphically, which means from a graph. And then third is the analytical stuff or algebraic stuff. Okay, and this is algebra. So the hint here is that A for algebra, A for analytical. Okay, but that's how one way, because I always used to forget when I was a student, how do you remember which? Now, when all fail, guys, when everything fails, the table is probably the best way to go, right? If you're ever confused, it's a table to go. If you have the graph, it will be nice. So you know about the table, right? The table just means draw a table, look at the number from the left and the number from the right, okay? And then the number from the left has to be the same as that from the number from the right, okay? For example, if I ask you, I'm jumping to 2.5 because I just posted that notes this morning and I had given an example that I worked out there. Yes. If I ask you, so let's look at an example. Find the limit at, let's say, x equals 2. Yes. Find a limit. Let's take this out. Given limit as x approaches 2 for the function x squared plus 2x minus 8 divided by x squared minus 4. Okay, so pay attention, please, because this is an easy process, but for some reason, sometimes we get lost in it. So if you look at the numerator of this function, oh, come on. If you look at, really? If you look at the numerator here, right? First of all, before you even look at the numerator and the denominator, if you, this is your, basically your f of x, right? Or g of x, this is the function, okay? So what is, and let's say the function, let's call it f of x, right? So if I ask you what is f of 2, f of 2 would be 2 squared plus 2 times 2 minus 8 over 2 squared minus 4. And if you do that, you'll get 4 plus 4 minus 8 over 4 minus 4, which is 0 over 0. Anytime, class, you have 0 over 0, you must stop. This is a hint that you have to either using some method of algebra, either factor the top, factor the bottom, rationalize. You have to do something. You plug it in is not going to work. Is that clear?
Yes.
Anytime you have 0 over 0, you have to do that. So if you look at this function, you will notice the numerator and denominator can be factored. Okay? So we can say that the limit as x approaches 2 for x squared plus 2x minus 8 over x squared minus 4 is the same as if I say it's the limit as x approaches 2 of x plus 4 times x minus 2 over x plus 2 times x minus 2, right? If you factor the top, you're going to get x plus 4x minus 2, and the bottom is difference of squares. So now notice what happens here is that this can be canceled with that, right? So what are we left with? We're left with the limit as x approaches 2 as x plus 4 over x plus 2. And now if you do a direct plug-in, right, which is what we call the analytical approach, okay, so the limit as x approaches 2 will be 2 plus 4 over 2 plus 2, which is 4 plus 2 is 6, 2 plus 2 is 4, so that is 3 halves. Okay, so this is called the analytical approach. Okay, now if you want to confirm, is this really true? Is there any doubt in your mind that this is false? Okay, so if there's any doubt in your mind, what you should do, you can use the check. You can use the graph or the table. Yeah. Please don't use a table unless I say use a table. Yeah. So what you will do is okay. What we're going to do is use the table and the function we said call it f of x. So f of x and x, and we create a table of values. Somewhere in the middle, we want to put 2. And then we choose at least three values to the right of 2 and to the left of 2. So some values on this side here, we can have 1.999, 1.99, 1.9. And then on this side, 2.0001, or let's make it 2.01. Okay, then 2.01, and then 2.1. And then fill in what is f of 1.9? What is f of 1.99? What is f of 1.999? Obviously, f of 2 will give you undefined. What is actually, no, that's not true. F of 2.001, f of 2.01, and f of 2.1. Well, if you plug in 2 into the function, right? Remember, f of x here is x squared plus 2x minus 8 over x squared 4. So when you plug in 2, as I said earlier, it is going to be undefined, right? F of 2 would be 4 plus 4 minus 8 over 4 minus 4. This is 0, so it is going to be undefined. But what you have to do is, what is this value here? And what is this value here? And they should be, based on your algebra, 3 halves. Okay, so let's just do it. Let's just, let's take a minute and do this, right? What is f of 1.999? Well, it's going to be 1.999 squared plus 2 times 1.999 minus 8 over 1.999 squared minus 4. Well, I happen to have my graphing calculator, so let's plug in those values. Okay, so 1.999 squared This is approximately 3.996 plus 2 times 1.999. This is approximately 3.998 minus 8 over 3.996 minus 4. So this here, if we add up those numbers, plus 3.996 minus 8, this is negative 0.006. And in the bottom now, if we have 3.996 minus 4, this is approximately negative 0.004. And if we do 0.006 divided by 0.004, this is positive 1.5. And I'm sure, right? I'm sure, or I'm confident that if you now do what is f of this value, 2.001, what would you get? And you should try that. And I'm almost sure that the answer will be approximately 1.5. You want to try it? Yeah. So if we do this, we're going to have 2.001 squared plus 2 times 2.001 minus 8. All of this divided by 2.001 squared minus 4. Okay. If we try those values in our calculator, 2.001, if we square that, we'll get approximately 4.004. Then plus, and I'm rounding, right? So that's why I said approximately. 2 times 2.001. This is approximately 4.002 minus 8 over 4.004 minus 4. So what do we have? Plus 4.004 minus 8. This is approximately 0.006, and the bottom will be 4.004 minus 4. This is 0.004. And then if you do that, you're going to get 1.5 also. So it's not even approximately, it is 1.5. So if this value here, right, this value here became 1.5, and this value is 1.5, therefore on the table, this is 1.5. This side here is 1.5. Because this is very, very close or the same, then the limit is 1.5. If those values are off, then the limit is not that value. So that's the algebraic calculation. Okay. Any questions? Okay. Now keep in mind, right, I just want to point out to you what you're doing here, this whole thing here, what you really did was, or is, the limit as x approaches 2 from the left of f of x. And this here is the limit as x approaches 2 from the right of f of x. Right, so you have to get into the whole idea of those abbreviations that we've been using. So this is the table, right? This is the table method, table. And this here is the analytical stuff. Okay. So the only problem is that you have to be careful. Anytime you have 0 over 0, guys, you have to stop. And you had a few of those in your homework. Okay, questions?
Professor, can we go over the squeeze theorem?
We can. I don't want to spend a lot of time on that because it's only for the engineers then.
Oh, okay.
But let's look at it. So generally the squeeze theorem is when you have one graph like sandwiched between two graphs, right? So if we look at the squeeze theorem, and I had actually let's look. So if we have these these three graphs here, and g of x, f of x, and h of x, and if f is between h and g, so f here is between h and g, and if we're looking at the limit at some point c, now notice at the point c, all three of these graphs reach up at the same point, right? So if the limit of f of x is, let's say, L, so this point on the graph here, somewhere over here is L, then for all three of those graphs, the limit is going to be L, right? But if you, let's say C was somewhere over here, and I'm going to erase this in a minute. Suppose C was here, then the limit of H would be different from the limit of G, which will be different from the limit of F, right? Although they're in the same point. So we're looking at some specific value for C. Okay, it's where all the height of all of the graph is the same. That's what really we're looking at. And that would answer your question, right? So the question would, what happen if this here is not the same as this? Then what happens here? Well, if these values are different, then obviously f of x is going to be different. Okay.
Yeah, I get it now.
Okay, so take a minute, guys, and try this problem. The first thing you should do is always analytical, right? Algebra. So if you use algebra, right, then the limit as x approaches 0 of the square root of 0 plus 1 minus 1 over 0. Well, we already see there's a problem here because you can never have 0 in the denominator, right? This is going to be equal to the limit as x approaches 0, square root of 1 minus 1 over 0, which is 1 minus 1 over 0, which is 0 over 0. And anytime you get 0 over 0, what must you do? Stop. This means that this is the indeterminate form. You cannot determine the limit. Indeterminate form. And you have to go back to the problem. And now you either have to factor or do something with this problem. So what is it that you think you can do with this over here? Is it possible you can factor the top or anything like that? What do you think you can do here?
You multiply it by the conjugate?
Yes, let's try rationalize, right? Try to rationalize. Okay. So we have the square root of x plus 1 minus 1 divided by x. Let's multiply that by its conjugate, which will be the square root of x plus 1 divided by the square root of x plus 1 plus 1. Right? Now notice the top is difference of squares, right? This here, when you multiply by this, you're going to get the square root of x plus 1 squared minus 1 squared. And then when you multiply with the bottom, you're going to get x times the square root of x plus 1 plus 1. Simplifying the top, we're going to have x plus 1 minus 1 over x times this times the square root of x plus 1 plus 1 on the outside. So at the top, we're going to get x, and at the bottom, we have x times the square root of x plus 1, then plus 1 on the outside. Now notice what happened. You notice I didn't try to multiply with the bottom, right? Notice in the top now, this will cancel out with this, right? The x will cancel out, as we say when we speak. So what are you left with? You're now left with the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. And now try algebra. So this is now equal to 1 over the square root of 1 plus 1 plus 1. So the limit as x approaches 0 is equal to 1 over the square root of 2 plus 1. And I don't know what the square root of 2 is off the top of my head, but this is approximately 1 over the square root of 2 using my nice handy dandy calculator. Okay.
I have a question.
Yes.
How did you get 2?
1 plus 1.
1 plus 1.
But isn't it 0 for
1
x?
plus.
As
Oh,
x
x is
approaches 0?
Oh, yes, you are correct. Why did I plug in? X is 0, yes. Thank you, guys. So 0, yes. X is approaching 0. So the square root of, then I need to take this out too. Thank you.
That's
So
right.
0 plus 1 is 1, right? So square root of 1, and then I have a plus 1 on the outside, which will be 1. The square root of 1 plus is 1 plus 1. So I don't need that famous calculator. So then this is not approximately, this is equal. So it is equal to 1 over 2. Okay. Any questions?
No.
So another question now, let's look at limit from the left and limit from the right, which is called one-sided limit, right? So one-sided limit. So one-sided limit. And one-sided limit really means limit from the left and limit from the right, right? That's really what it means. So if I give you an example, right? You know how to find limit. Suppose I ask you, find the limit. Let's say the limit as x approaches, let's say 1, okay, for the function 4 minus x squared. Okay. Well, can you do this using algebra? Do you think you can do this using algebra?
I'm not confident.
No. Try it. Okay, you have nothing to lose. It's either you get 0 over 0, but you know you have to stop. So let's try algebra. Let's try it.
Professor, sorry, maybe it's a stupid question. And why
No,
you say one side limit? Why one side?
Well, the topic is one-sided limit, but we didn't get to one side. I'm asking a general question. This is not one-sided. Okay? I'm getting to what is one-sided. Well, if you try this, you're going to have the limit as x approaches 1, the square root of 4 minus 1 squared, which is really the limit as x approach 1, the square root of 3. And that's your answer, right? The square root of 3. Actually, I need to take this out too. Once you plug in that number, okay, you don't write limit anymore. So the square root of 3, that is approximately 1.73. 1.73. So the limit as x approaches 1 of 4 minus x squared is approximately 1.73. Now, suppose now I ask you, what is the limit? So a different example now. What is the limit as x approaches 2, okay, from the left side of the square root of 4 minus x squared? Well, what does this really mean? What does this mean? What does it mean? Well, it means, guys,
Negative
if
side.
you can, what's that?
It's on the negative side of the x-axis of the graph. Sorry.
Don't use the word negative for me.
Oh, it's on the left side.
Very good. It's from the left side of 2.
Yeah.
Right? Because when you start saying the word negative and you're under a test, what may happen? You may go look at -2.
Okay.
Do you follow?
Yes, I get it.
So all this will mean, imagine a table, okay, with values from the left side of 2. So imagine this, right? Here you have 2, right? What is a value to the left side of 2? What is a number close to 2 here? What number do you put here?
0.999.
1.999, yes. Okay, so try that value. Try 1.999. Okay, and you can try 1.99 and see what happens. So if x is equal to 1.99, then you have the square root of 4 minus 1.99 squared, right? What is that equal to? Well, 1.99 squared is 3.96 approximately. So 4 minus 3.9601. And the square root of that, 4 minus that, and then take the square root of it. This is approximately 0.1997. Well, what happens if x is equal to 1.999 now? What do you get? Well, you get the square root of 4 minus 1.999 squared. And 1.999 squared is approximately 4 minus 3.996. And 4 minus that answer, and then
0.004,
take the square root, yes. Right?
0.063.
I'm about to check that. So second function, answer second function, square root. This becomes approximately 0.063. So look, when you try 1.99, you get this value. When you try even closer, you're getting this value. Where do you think you're approaching? Is the value getting bigger or smaller?
Bigger.
Smaller.
Smaller, right? This is smaller than this in comparison to this. You can even try another value. What do you think will happen if you have x is equal to 1.9999? You will see it will get even smaller. And that's smaller, right? I mean, try it, guys. Can someone tell me what happens if I do this? 4 minus 1.9999 squared. You're going to see it's going to be approximately 0, close to 0. Okay? Jaden, you got these numbers?
0.02.
0.02. Is it close to 0? So that limit is approaching 0. Right? So this is one-sided limit. So what you were doing here, so here we can say approximately 0 or is equal to 0. It's going to be equal to 0. Okay? So this tells me that the limit as x approaches 2 from the left side, okay, the square root of 4 minus x squared is equal to 0. Let's remove this from here because we didn't know that at the beginning. Now, look at why we need to know one-sided limit. If we have the xy axis, it's horrible. This is supposed to be a semicircle, right? 4 minus the square root of this. Can anyone tell me how do I know that this is a semicircle? For those of you who had me in pre-calculus, you should know the answer to this. Why is this a semicircle? How can I look at an equation and know if it represents a semicircle?
I don't remember now.
You don't remember, okay. Anytime you have under a square root, the difference of two perfect square, it's always going to be a semicircle. So 16 minus x squared, this is a perfect square, this is a perfect square, right?
Yeah.
This is a semicircle with radius 4. Okay. So well, it doesn't even have to be a perfect square, but a perfect square is easier to see. The radius is going to be the square of that number. Now, remember, when I ask you the limit as x approaches 2 from the left side of this function here, f of x, which is equal to the square root of 4 minus x squared, okay? What I'm really asking you is what is the height, okay? What is the height at x equal 2 from the left side? So walking along this graph from this side, not from this side here, okay? From this side here, if you walk on this graph on this side, that's what we mean. What y value do you reach? Okay? And this is where we said that the limit is equal to 0 because you're going to come to some y value here, right? Y here is equal to 0. The limit is the height of the function at the given x value. So here's my next question to you. Here is the big question. What is the limit as x approaches 2 from the right side now of f of x? Look at the graph. What do you think?
0.
Excuse me?
I think it's 0.
0. Who is speaking?
Raven.
Raven. So here's the question. This means, okay, what does this here mean in English?
Approaching 2 from the right, or right?
Yes,
2.
approaching. It means go on the graph and travel on the graph, okay, 2 on the right side. So let's go now. Look at what I'm doing. Pay attention, guys. Pay attention. Look at what I'm doing. I'm going now from the right side on the graph. Where is the graph on the right side of 2? Do you see a graph on the right side of 2? Yes or no?
No.
No, there is no graph. So you can't even do this. Does not exist. It doesn't exist on the right side. So from the left side, it exists, but from the right side, it doesn't exist. Okay? So if you had made a table, right, would the left side value be the same from the right side value?
No.
No.
No, it wouldn't. That means the limit wouldn't even exist at the point 2. Because if the left side is not equal to the right side, the limit doesn't exist, right? The limit exists from one side, but not from the other side. So this is kind of like pushing us into what we're going to learn today in your lesson today from the notes that you have is limits at infinity. Okay. What do we mean by limits at infinity? Is vertical asymptote and horizontal asymptotes. And you guys know how to find vertical asymptote from a pre-calculus perspective. But you're more concerned about it from a calculus perspective. Okay. So anytime, right, in general, if in doubt, okay, look at a table. Okay. If in doubt, always look at a table.
Professor,
Yes.
is there any way to determine the limit as it approaches 2 on the right side without the
No.
graph?
Yes. Do
Okay,
exactly what I did here.
you can do it algebraically as well?
Yeah, sure.
Okay.
Okay. If you had a question here, how do you notice and you don't see it, right?
Mhm.
Try f of 2.001, then f of 2.01, and then f of 2.1. You will see that each one of these values is undefined.
Yeah, I got an imaginary number.
Right. Undefined. Same thing will happen here. Undefined. Same thing will happen here. Undefined. And from here, you get that.
Okay.
Right? If you plug in bigger numbers, you will find that you're getting this number here is going to be larger than 4. So you're going to get a negative number under the square root. A negative number in the square root is undefined, meaning the limit doesn't exist. Okay? So you guys want to try one?
Sure.
Let's try example, limit as x approaches 3 from the plus side, 2 over x plus 3. So try that one for me. I'm going to the cafeteria. I'll be right back. So now we're looking for the right side. Okay, this means the right side of 3. So what are some numbers to the right side of 3?
3.001, 3.0.
3.001, 3.01, 3.1 even, right? So those are the numbers really you're plugging in. So what's going to happen if you plug in x equal 3.001? Well, you're going to have 2 over 3.001 plus 3, which is equal to 2 over 6.001, right? Which is approximately what?
0.33.
0.33. Let's see what happens here. X is equal to 3.01. So this has become 2 over 3.01 plus 3, which is 2 over 6.01, which is approximately 0.33. And if you try x equal 3.1, you're going to get 2 over 3.1 plus 3, which is 2 over 6.1, which is approximately 0.33.
3.
So you can clearly see that they're all about the same number, right? So you can conclude that the limit as x approaches 3 from the positive side of 2 over x plus 3 is equal to 1/3. 0.3333 is 1/3, right? Okay, that's it. So limit from the left and from the right just means to plug in some number from the left side or some number from the right side.
I have a
Professor.
question.
Yes. Hold on.
It's 9:56, sir.
No, hold up. Two people talking, so I heard the female voice first. Continue.
Okay, so when it comes to a problem similar to this, because if you just plug in 3 from the original equation, we get 1/3. Do we even have to do the table to make sure, or can we just use the substitution method?
Because it's, say, from the right, you cannot plug in 3. 3 will be wrong.
Okay,
You have to plug in a number just past 3.
okay, because I did that also, but when I plugged in 3, I also got like, when I plugged in the 3 from the equation, I got 1/3 too.
Yeah, you will get 1/3, but mathematically that's not right.
Okay.
Yeah. Questions? Somebody else was asking a question. Was it Jaden?
No, I was just reminding you of the time. Because you said,
Okay, yeah. All right, so let's wrap it up. Let's wrap it up, guys. Okay, so notes is already posted on Blackboard for your next section, which is the last section of chapter 2. We'll finish chapter 2 today, okay? And you will have homework and so on.